Hi guys, so they want us to use Thevenin's theorem to solve the circuit. First, want us to find the equivalent circuit at AB, quite tricky, and then find IX. So the first thing you want to do is you want to find RTH, and then you want to find VTH. But first, let's find RTH. RTH is basically to find that you off all the independent sources. To off this, you short circuited. To off current source, you open circuited. So this circuit is going to look something like this. Now, Canada is very confusing. So what you're actually going to do is that you're going to find the resistance at this point, that is at RA, and then find the resistance at RB, and then total it, and that's how you can get your total resistance. So the resistance at RA, these two things are in parallel because they share two different nodes. So it's going to be 10 in parallel with 10. That's simply 5 ohms. And then at RB, what do we have here? Just 5 ohms. And then when we add it, RTH is going to be what? 10 ohms. And this one's a bit tricky for me as well. And now for VTH, you're going to go with a similar tax. You're going to go with a similar tactics, which is like VTH equals to VA minus VP. So let me draw the circuit out. So in this particular case, you're going to find VE. So what is the voltage at this point? It's simply going to be 10 over 10 plus 10 times 20 volts, which is going to be equal to 10 volts. So at this point, what you have is 10 volts. This 10 is actually this 10 on top here over 10 plus 10. So do not be confused. Then VB is equals to find the voltage at this particular point is going to be equals to, this is simply a current, this is simply a resistor. My brothers and sisters in Christ, like it's just AR, it's just 2 times 5 equals to 10 volts. So that means VTH is going to be equal to 10 minus 10, which is equal to 0 volts. So in essence, there's no voltage at this particular portion. And so therefore, when you draw out your equivalent circuit, so the equivalent circuit is basically VTH in series with RTH in series with the load resistor RL. And then to find the current going through it, which is IX, is simply going to be IX equals to VTH over RTH, which is equal to 0. This is our final answer. Thank you for listening.